Hello, it's Scott Manley here, and yes, I'm still getting bombarded with questions regarding yesterday's incident. Anomaly. Look, it was an explosion. Some people say it wasn't an explosion because it didn't detonate, but no, that is an explosion. So this video is by uslaunchReport.com, which is basically a number of disabled US veterans. It's a non-profit organization, and they're basically doing coverage of space programs, space operations, and they were the only people on the ground, or the only third party that was recording the test, and therefore they won the jackpot in terms of footage. So you should definitely check them out, and maybe even throw them a donation for performing this great service that gives us so much to discuss. So this is the video with the audio resynchronized to remove the speed of sound lag. They were a couple of miles away, so it was taking several seconds for the audio to get there, and the video is more impressive, more telling when you have the audio synchronized. Okay, you can see that I held back and chose not to talk over that because, yes, it's worth embracing. Okay, I mean, you saw what happened there, you saw the explosion starting in the second stage, but of course, this is a 60 frame per second video. We can rewind and we can go back and discuss in detail what happened. So running at a quarter normal speed here, there is nothing to see before the explosion. Everything looks normal, and then it just happens. There's no fuel leak or anything. Now as the explosion progresses, you can see the fuel from the second stage cascading down, falling towards the pad, and then somewhere behind that wall of flame, the main booster loses integrity, and that is the main explosion. Now that's just basically a wall of fire, fuel and liquid oxygen mixing. And then out of this emerges the Strongback tower, and interestingly enough, still attached to the top of it for a moment is the payload inside its fairing. And of course, its brief respite from this explosion is not to last, and it descends 50 odd meters towards the ground. Payload must still be inside it at this point. You can see some of the structure on it, and then it too explodes. Now its fuel was hydrazine, and the color of that smoke there, that is nasty, nasty stuff. There's also xenon propellant inside there, but that's largely inert and wouldn't have any real effect on the conflagration that is progressing. There are secondary explosions that continue to happen for some amount of time. It's very clear from this footage that they will not be rebuilding this pad anytime soon, and it will be closed for investigation, so they will no doubt be fast-tracking 39A to get it operational. Again, we can go back and look at some very specific moments and see if they provide any clues. So, once again, the last frame before the explosion happens, everything is normal. This is what everything appears correct, right? There's no clue in this. The explosion starts in the next frame, and it is a big conflagration immediately. This is running at 60 frames per second, and given the size of it, you can tell that this flame has appeared immediately and is moving practically supersonic. So this is under a lot of pressure already. There is no delay, there is no fuel leak that is apparent beforehand. The ignition happens before any leak is evident. Now we can also use the lens flare here to try and triangulate on the center of this mass. So I'm just drawing lines through the lens flare, and then through a bit of magical trickery, you can see, yep, that's right in the middle of where the fueling interface would be for the second stage. SpaceX seems to love their first stage boosters, but they appear to be having some problems with their second stages, if you ask me. Anyway, a fraction of a second later, the explosion is so bright that it's actually lighting up everything around it. If you look at the tank in the bottom right corner, and I flip back and forth between frames, you can see that definitely there's an illumination coming from that. So the explosion's pretty darn bright at this point. And of course, as the sequence goes on, the camera automatically reduces its exposure. Anyway, the next interesting frame shows clouds of oxygen forming around, being pushed outside of the explosion. Now, it's not a detonation, this is an explosion that is traveling subsonic, and it's pushing the contents of the upper oxygen tank out in around it. It's also interesting to note that the explosion is much more horizontal than it is vertical. This isn't really that surprising because the fuel tanks are kind of cylindrical with spherical end caps, and so they will tend to be weaker around the edges than they are around the end caps. And of course, when I say weaker, I mean they are very well built, they're just not built to handle explosions. In the next still, we see the fuel from the second stage tank pouring down the side. The tank has ruptured and the force of the explosion is pushing this downwards, and it's essentially burning on contact with the air. Note that this flame is a lot less intense than the main explosion because this is essentially being supplied by atmospheric oxygen rather than the oxidizer in the main tank. But of course it's sitting on top of another tank of oxygen in the booster stage, and if we play this forwards, watch the flames as they fall down. There's a puff of oxygen that basically is coming out of that second tank, and when that flame front hits the cloud of oxygen, you see it suddenly flashing into flame right at the bottom. So that's the fuel from the second stage and the oxidizer from the first stage combining and reacting. So this first stage is losing structural integrity by this point. And it's just a matter of time until the fuel tank on the first stage ruptures, spreads fuel everywhere, and we get the biggest component of the explosion happening. And for those of you wondering, a fully loaded Falcon 9 full thrust has almost twice the amount of fuel that the Antares rocket had. Therefore, this is probably the biggest explosion, at least happening at this altitude in US rocket history. Now, this is obviously going to be a serious setback for SpaceX. A disaster of this magnitude will not go without lots of ground time, lots of tests. So I expect that SpaceX may pull all their launches for at least the rest of the year. The payload was, in fact, insured by marine cargo insurance. Technically, launch insurance doesn't kick in until they deliberately fire the rocket, and this was not a deliberate ignition. And SES have apparently told journalists that they're still okay with the prospect of launching their spacecraft on board a flight-proven Falcon 9 rocket. And indeed, why should they have any worries? It appears that the problem is with the second stage and not the first one. NASA has so far been silent on the issue, besides issuing a statement about how rocket science is hard. But of course this does bring up the question, what about the NASA commercial crew program? Would it be safe to put a crewed spacecraft on top of this? Well, as it turns out, there's a way we can test this. SpaceX have previously carried out a ground test of their launch abort system, so it should be possible to edit this footage together to see just how fast the crew could have escaped that giant fireball. And of course we can play these two sequences next to each other and get an idea of, yes, you know, this thing does take off pretty quickly and put them a long way from the rocket, but we can do even better. We can essentially composite the two videos on top of each other and watch it fly to safety. Maybe a little bit toasty, but hopefully still alive. But let's remember, all this footage comes from uslaunchreport.com, and I'm very grateful that they did this. This is probably the only good footage we're going to see of this, unless SpaceX publishes an accident report with it. But they've been doing a lot of other stuff. It's definitely worth checking them out. So thanks to US Launch Report, thanks to you for watching. I'm Scott Manley. Fly safe.